Hello everybody and welcome to the first video in our next chapter. So this is Foundation of Mathematics 20. This is acute triangle trigonometry and the topic for today is law of sines. So the first thing we should talk about are acute triangles. Acute triangles are triangles in which all angles are less than 90 degrees. So an example really quickly, each angle is going to be acute, so less than 90. So that could be 60, that could be 40, and then that adds to 100, so that forces this one to be 80. So that is an acute triangle. So all the triangles we're going to see in this chapter, the angles are going to be less than 90. So there's no 110s and things like that. That would be an obtuse triangle. We're going to look at that next chapter. So law of sines. That's a formula that allows you to determine unknown angles or side lengths within triangles. Unlike the trigonometric ratios that work only with right triangles, the sine law works within any triangle. Okay, so we could use this in a right triangle. We can use this in an acute triangle like we're going to, and even in an obtuse triangle. But the way your textbook breaks this up is with acute triangles only first. So I will follow that because sometimes it's easier just to follow the textbook when it comes to assignments and things. And then for this chapter, we'll only focus on acute. Okay, so law of sines, the formula itself. So I'm not sure if you could see that. That was not the best that I could have chosen. But if you have a triangle, okay, and you can see it's here. Okay, and if I call this A, this is B, this is C, then in triangles, we always name the vertexes, the angles, the capital letter, or we can do it this way, the capital letter, and then the side across from it, the lowercase letter of that angle. So if this is big A, then we'd name this one little a. So this is big B, we'd name this little b. If this was big C, we'd name it little c. All right, so from that, we get this right here. This is the sine law or law of sines. You can say it either way. Now, it's got three parts to it, right? It's got three fractions being equal to each other. What that's telling you is that when you do this calculation, which we're going to do right away, when you take the side length and divide it by sine of whatever angle you have, okay, so A there, you'll get a value. And then if you do it with B and sine B, you'll get the exact same value. And with the C's, you get the exact same value. Okay, so it's kind of an interesting property where there's the same value will pop up throughout the entire triangle. Now, as you guys know, we're not used to using three fractions, so we'll only ever use two. So you can use any combination of two. So if it's the A and C, great. If it's A and B, great. If it's B and C, great. Okay, so we're just going to use 2 out of 3 all the time. All right, so here's that demonstration I'm talking about. Again, blue's not the best, sorry about that. So if I just take A divided by sine A. So I would get, I forgot to write that number down. So 8.62, that's an 8, so yellow's much better, hey? Moving forward, Mr. Troy, maybe use yellow. 9.99, and this is going to be 12, and I'll put it to two decimal points because that's what the other ones were in. Okay, so now, so side A, 9.99. over sine 55. And if you grab your calculator, and I'll grab my calculator and do it in real time with you, 9.99 divided by sine 55. The one thing you always want to make sure is that you're in degrees, by the way, with your calculator. Okay, so I'm just going to round this to one decimal place. So I'm going to get 12.2. Okay, so next one, B over sine B. So B ends up being 12. Over sine 80. $12.2. And then C over sine C. So C that's 8.62 divided by sine 45. And again, this is me just calculating real quick, 45, 12.2. Okay, so you got that same value going across. So that's going to happen in all these triangles. And that's why it's actually like you've seen Mr. Troy make right triangles on the board really quickly because they're easy to make. But these acute triangles, I can't just make them up on the fly. I actually have to make sure things make sense. So anyway, so that's that property of that common value going through, okay? And that's where we can make that, that relationship A over sine A equals B over sine B equals C over sine C, and then we choose any two. By the way, you could also write it like this. Okay, it doesn't matter. And there's actually uses for either way. I would say the more traditional way is the one I presented first, but it doesn't matter which way we do it. Okay, so let's look at an example now, solve this triangle. Okay, so the first thing, I like making a little list. Okay, and I'm going to write down what I know. With this stuff, they need to give you 3 pieces of information. If you don't have 3 pieces of information, then you can't move forward. All right, so angle A is 65. Angle C is 35. And what else do I know? Oh, I know side C is 41. Again, if this is big C, then across it is the lowercase. Okay, everybody? Okay, so now when they say solve a triangle, by the way, that means find all the missing information. Okay, so we have to do that here. Now the order doesn't matter. There's sometimes a smarter order. Sometimes you could do just, there's a few different ways you can do it. But yeah. Okay, so the first thing to know when you're using sine law, you need one complete angle side pair, meaning you need to know an angle and the side length. Okay, so if I look here, with C actually, I know C, like angle C, and I know side C. So because I have that angle side pair, I can use sine law. And down here, this is one thing that makes this really nice to use is that when you have a complete row, you know you're good to go with respect to sine law. Okay, feel free to use that silly rhyme. So because I have this row, I know I'm good to go. All right, now it doesn't matter what you want to find first. Remember, we're going to use just 2 out of 3 of those fractions. So in both of them though, I'll have to use C first. So I'm just going to write C over sine C equals. Okay, now I'm going to choose the other one. So I'll just go top down here. I'm going to look at A first. So in A, you can see in the A row, you have 1, but you have 1 unknown. So you know 1, you don't know 1. We're going to find the thing we don't know. Okay, so 41 over sine 35. So what we're doing, we're using the sine law to create a proportion, everybody, and then you solve the proportion. Because remember, a proportion are just 2 fractions that are equal to each other. So, and then I don't know A over sine 65. Okay, and then like I said, we solve it like a proportion. So I can cross multiply. I always bring my variable to the left side. So A times sine 35 equals 41 times sine 65. Okay, and then you divide by sine 35 because I'm trying to get A by itself. Now, one of the hardest things, because people typically don't find sine law very difficult, but it's just making sure that you using your calculator properly, so the keystrokes. So you might need some help with that. I'm just going to do what I see here, 41 times sine 65. Then I'm going to hit equal so I know the top. Then I'm going to divide it by the bottom, sine 35. So I did it in 2 steps. You don't have to. You can do it in 1 step. And then I'm going to go to 1 decimal place again. So I'm going to get 64.78, so 64.8. Perfect. So that would be A. Okay, and then let's go to yellow this time. Let's see if I can't squeeze it in over here. So this was the first one, and I'll put that in 64.8. That looks nicer on the eyes. For B, well, first of all, if I'm looking at angle B here, everybody, you can't use sine law when you don't know either of the side lengths or the angles. So I don't know angle B and I don't know side B. So I actually am stuck. I can't use sine law right now. But thankfully, based on what you guys know about triangles already, if you think about this here, this is getting messy, but at least it's colorful. I have 2 out of 3 angles in the triangle. So for angle B, so this was A, this is B, I'm just going to go 180 minus the 2 I know. So minus 65 minus 35. Okay, so what is that? 60 and 30 are 90 and 5, so that's 100. So 180 minus 100. So then I know this is 80. Okay. And now that I have one of those pieces, now I can use sine law to find the other one. Okay. We are running out of room, people. But we can do this. So it doesn't matter which one you start with. So I'll say C over sine C equals B over sine B. So then I get 41 over sine C. Actually, people, what am I? Yeah, no, I'll keep doing it. I was going to say, I have another slide behind this, but you know what? I don't have some of the numbers written down. So I think I'm going to try to continue to squeeze this in. B over sine 80. Okay, then I'm going to cross multiply and solve. And yes, no, I do see that if you're like, oh, Mr. Troy. Okay, that's where I was thinking about that other slide. So this is 35. Okay, so this is me. I'm going to, of course this is me. I'm going to cross multiply now. So unfortunately, I'm going to have to slide over here. So sorry about that. B over sine 35. And then 41 times sine 80. Oh man, we're getting tight. Divide by sine 35. Divide by sine 35. B equals, okay, and this is me. I'm going to do it. I don't know, why am I saying this is me? Of course this is me. Anyway, I'm pausing to do the calculation is what I'm really trying to say to you. 70.1, so I have 70.4, sorry. So 70.4. Okay, now we, yeah, that's all we have to do in there. Okay, I was just going to say something else, but that's not till another example. So sine law is truly, it's an access to creating a proportion. So because the sine law, we can use that sine law to create a proportion, and then we just solve it as usual, cross multiply, divide. Okay, so we're going to reuse some things we know. So this is my backup that I could have used. Anyway, example 2. So I think I've learned that this looks better, clearer, and easier on the eye, so I'll use yellow. Okay, so what do I know? Well, I know A. I know C. I think that's what we knew last time as well. B we're wondering about. Side B is 10. That's all I have. Okay, they give us 3 pieces of information. We find 3 pieces of information. So in the first, in this question here, if you remember last time I said I need a completed row or that angle side pair. So I do not have that. So I'm stuck. So you have to do some thinking. Is there a way you can give yourself a row? And hopefully you do think there is a way. I'm going to switch to green here. I'm going to switch back to yellow. Okay, so I can find angle B really easy. Okay, because I can do my 180 trick. So 180 minus 55 minus 25. And what is that subtracting? That is subtracting 80, it looks like. So I'm going to get 100 there. Well, that doesn't look so bad, that color. Okay, so that's 100. Okay, so now we can get into solving for the side lengths. So I'll just go with the A first. It does not matter which one. So like I could go A or C. If you don't want to write that initial step where you go, B over sine B and all that kind of stuff, you don't have to. So I'll give you an example. I can just get right into 10 over sine 100 equals, and we're looking for A, I said here, so it'd be A on top, sine 55. And then just start solving. A times sine 100, 10 times sine 55, divide by sine 100, divide by sine 100. And let's figure out what that is. So I'm just going to pause to calculate here. Okay, I'm getting 8.3. And again, make sure you are in degrees, everybody. Now, we haven't talked about units, so if a unit is not mentioned, and it's not mentioned in my diagram, you can just put U for units. And what that tells the person who created the question is whatever you're counting by, it's 8.3 of those things, yards, meters, whatever it is. Okay, so 8.3. I'm going to try a little bit of a skinnier, yeah, let's try it. Let's stick with that. A skinnier ink, okay, or a pen. Okay, so I'm going to look for C now. So same thing, I'm going to start with the fraction I know, so the A over sine A. But there's actually a little shorter way. I'm going to show you a bit of a shortcut. If you always put the thing you're looking for on the top left, so meaning C over sine 25, okay? And then now over, I have to have my completed fraction, so that's going to be 10 over sine 100. So I'm saying top left, like that's kind of the top left. If you think of this as a box, okay, top left. And then what you can do here is, I guess we'll cross multiply still. C times sine 100, 10 times sine 25. I think that's easier for you to read, this skinnier pen. Sine 100, sine 100, C equals whatever it's going to equal. I want you to, I guess I'll figure this out first, and I'm going to point something out. So I'm going to pause here again just to figure this out. 4.3. Okay, so that's my answer. Put it in the orange here. Now, back to the shortcut, because that wasn't really a shortcut there. That was the exact same amount of work. Well, what I want you to do is I want you to notice the sine 100. Sine 100 starts in the bottom here of the right. Then it gets multiplied over to the left. And then you have to divide by it. So it ends up moving back to the right. So yeah, you never need to change it, to move it, sorry. So a shortcut when you're doing this, if you put the unknown in the top left, all you really have to do is you have to just do half the multiplication. So we do cross, we only have to do the one side of it. So I could have just went 10 times sine 25 and then left the sine 100 on the bottom. And then you can see that's what it looks like right here. It's 10 times sine 25 with sine 100 on the bottom. And yeah, it's a little bit of a shortcut and you get the exact same thing. This is already short though, so I don't know if you really need a shortcut, but there is one. Okay, so that's example 2. Let's look at one more example. And then I have a second video talking about problems. And I will not use blue on that, okay? I'm learning some things. I haven't made a video in a little while, with this program at least. Okay, so this is optional, the angle A, angle B, angle C thing. Okay, again, I think it's nice for organizing, and it kind of highlights what you have and you don't have, so I think there's lots of benefits to it, but it's not essential. Oh, I saw that too. That was example 2 again, right? So here's example 3. Our last one. Okay, so I only have one angle, 71.5 degrees. I'm looking for side A. Side B is 9.4. C is 9.1. Okay, so this is a different arrangement. There's only really 2 types of triangles you're going to see. They're going to either give you 2 angles on one side. That was what the previous ones were. Or they're going to give you 1 angle on 2 sides. That's what this one is. Okay, so there's really only 2 different ways this goes down. And neither of them are crazy hard. So it doesn't really matter that you know that there's 2 types, but yeah, you will notice that. All right, so we need to have a completed row. Okay, we do, so we're good to go. All right, so when you're doing, if you see the row, we know we have sine law. If you're not using this little row technique, okay, what you want to do is you can just kind of go to your picture and you see, oh yeah, okay, I have my angle and the side opposite it, so I'm good to go. See, it doesn't rhyme, so that's why you need the row. Anyway, Okay, so it looks like to me there's only one thing I can find right now. I can only find angle B. I don't know either angle A or side A, and remember, we can't find one without the other. You need one of those two things. So I got to find angle B first. And again, there's nothing new with what I'm solving for, though. So let me show you my shortcut now, like legit shortcut, though. Legit, meaning I'm just going to do it. So seeing I've explained it once. Okay, so sine B over 9.4, sine 71.5 over 9.1. And again, what I'm saying is you only have to, for the reason I showed on the last slide, you only have to do half that multiplication. So 9.4 times sine 71.5 divided by 90. Oops, not 91, 9.1. Okay? And then now, when we're finding an angle, everybody, that says sine B. Well, I don't want sine B, I want angle B. So what we have to do is we say, well, angle B is equal to the inverse of that. Okay, so that's inverse. Again, you've likely seen this with right triangles, right? Easiest way to explain it here is really with your calculator. Your calculator's kind of programmed to, if you give it the value, it's going to spit out that. If you give it the angle size, it's going to spit out the value. We're going to give it the value. We want to spit out the angle, so we're kind of saying go in reverse. Okay, so got to plug that into your calculator. And again, keystrokes, I can't really teach you keystrokes through a video, everybody. You're going to have to kind of do that in real time. But seeing you have these answers, you can kind of play around until you get it. So I'm going to go second function sine on my calculator because I can see the word sine. If you hit the word sine and you see the word sine, you can follow my steps. If you hit the word sine, it looks like sin on your calculator, S-I-N, but sine, and it just kind of blinks at you, then what you'll have to do always first is put the numbers in first and then hit sine afterwards, or second function sine in this case, okay? So I'm going to type in the way I see it. I like to use brackets though, so I'm gonna, yeah, I can't really explain that in the video though, unfortunately. I'm still here, sorry. I had a mistake on my calculator and then I was like, oh yeah, you're in a video. Okay, so I got 78.4. Okay. Now, we'll always be able to check, by the way, because these angles should add up to 180, but because we're rounding, it might be like 179.9 or 180.1 or something like that sometimes. Okay, the second part, I will find angle A, and for that, you're likely thinking, oh yeah, I can do my subtraction trick. Yes, you can. Okay, 180 minus 78.4 minus 71.5, and sorry for the messy writing there. I'm going to do that on my calculator as well because I've got lots of things going on here. 30.1. Oops, 0.1. Okay, and then now I can find side A. All right, and if you want to use a shortcut or not, I'm not going to use it this time just because sometimes it confuses people. So I'd rather not confuse you. So I'll start with the thing I know, the given 9.1 over sine 71.5. You can absolutely use, so these are the C's. You could use the B's if you want, but if you got angle B wrong, then you're going to be destined to get this answer wrong. So if you use your givens, the C's, then you could get, I could have got angle B wrong, but I could still get, well, I guess in this one I can't because then my angle A would be wrong. But in theory, you can get more things right, like your mistakes won't come back to haunt you as much. Okay, so A over sine 30.1, and then now we just go through, I think, the familiar steps. So I've just cross multiplied, although I only showed the one arrow, that's okay. Now I'm dividing because I want to get A by itself. The way you move something to the opposite side of the equation is by performing the opposite operation. That was A times sine 71.5, so to move it, I have to divide. Okay, let's go. 9.1 times sine 30.1. And then divide by sine 71.5. And I'm getting 4.8. There we go. Okay, people, so that's sine law. So again, sine law is that property that if you compare the angle, if you go the side length divided by sine of that angle, that's opposite that side length, you're going to get a common value through the triangle. That allows us to build a proportion, and then we just solve all these using proportions. All right, so sine law, that's the basics. Next, problems. If you have any questions, make sure you contact your teacher. If your teacher's me, contact me. See ya.